Assalamu alaikum wa rahmatullah. Welcome, dear students. This is Mr. Abdurrahman, and this will be a quick overview on the chapter 4 and section 1 of chapter 5. So, I recommend you bring a paper and you write your notes along the way. Starting with chapter 4, chapter 4 mainly discuss three topics, which is the topic of work, energy, and power. But the way that they discuss it through four sections, which means they add a section here, which is the section of conservation of mechanical energy. That concept is actually very important for grade 12, so it's something that we will need to pay attention to. Anything else is just basic work, then energy, then power. Then we will go to the first concept or the first section that we have, which is section 1. In section 1, the book actually teaches about work in two steps. The first step, we need to understand what is the definition of work and what does it actually mean in physics. Then we can go to the direction, I mean, sorry, not the sign of it. Because as we discussed in the class, we said work is a scalar quantity, but it have a sign, which is a special case in physics, because logically, in physics, the quantities are two types, either scalars or vectors. When they are scalars, they don't have directions, which means they don't have sign. But work comes as a special case because it have a sign. Let's see that when we start. First thing, the definition of work. Work is a scalar quantity that requires what? That requires a product of force and displacement. Why do we say component of force? We will actually need to clarify this through some images. So the main thing that you need to know here is that work is a scalar quantity and it's a product of force times displacement, F times D. Let's start. So as you can see here, there's two things that we mainly need to pay attention to, which is the force that the um, anything basically apply force, right? So the applied force on the object and the displacement that the object moves. So these two things that actually specify the work that we have. In this object, you can see that the person is pushing the object, so he's applying force on the object and the object moves, specific displacement. So these two things what help us find the work. Then what is the benefit of the cosine in here? We will need to understand this concept. So let's take a look at this case. The main purpose or the main benefit of the cosine and the equation here is that it tells us that when you apply a force, such as this case in here, the person is applying a force at a specific angle above the horizon. When this case happens or occurs, the force that is being applied is not all being useful. And here the 15 newtons is not being used in total, and it's not being beneficial. What is being used in it is only the horizontal component, which is causing this cord to move horizontally. So basically, the cosine in here is used as a limitation tools that tells us how much we are using out of the 15 newtons. This is a very common thing in physics that we will be dealing with actually throughout grade 11 and 12 all the time, which is when you have an angle, you have always a components. So keep that in mind. The main purpose of it in here is that it gives us the usable force that we need, which is the force that is in the direction that we desire to move on, which is here the horizontal component. Then we now go to the equation. We start worrying about how we um, measure or how do we yeah, basically measure the quantities that we have in this equation. So work is a new quantity for us, so we need a new unit to it, which is the joule. Joule is basically the thing that we will use to measure two things, work and energy, which is a new unit. Then we have the force, which is already being discussed in chapter 3, is measured by newtons, then displacement by meters, and theta. Theta, guys, as you know, it's what we use to measure, like what we use to present the angle. Yani theta is the symbol of the quantity of angle. The unit of it is, as you know, in math, or like if you studied physics very well, you will know that theta, the angle, can be measured by two measurements, degrees and radians. And here in physics, till now, we are basically using the degrees, which is the default measurement for angles in physics. So here, normally, we use degrees, okay? But what is special about this theta, specifically about this equation here, that this theta is the angle located between the force and the displacement. Why is it so? Because both of force and displacement are vector quantities. They are both having an arrows. So the angle between those two arrows are the theta that we are looking for in here. So that's it. Now we have a very important thing for the Wazari and for our exams also, which is I need you to keep in your mind that the units that we have in physics are mainly five, the five fundamental units of physics. They are actually seven, but I told you that the most important are five, which are basically kilogram, seconds, and length, and ampere, and Kelvin. Those five are the five fundamental units of physics. Joule is not among them. So how do we get Joule to be a fundamental one? We say Joule is coming from this equation, which means it's newtons times meter. Newton for force and meter for displacement. Meter is a fundamental one, but Newton is not, so we also open it. How do we open it? We say Newton equal to what? F equal ma. So F in Newton equal to m kilogram mass in kilogram, and a, which is acceleration, which is meters per second square. We put it back in here and we multiply it by this meter. Meter by meter is now meter square. This unit is very important for the exams. Okay. Now after we know that, we can go on to learn new things. Here we can see that what we discussed earlier, which is when you have a force applied at a specific angle, this is not going to be a usable force, yani not in total. What we'll be using from it, I mean, is only a component of it. In this case, the horizontal component, because here we want to move this box horizontally, a horizontal displacement. So you can see that the force is being acted at an angle. This force is not usable. What is usable from it is this, which is F cosine theta, which is a component of it. So this is what we are focusing on in here, which is the theta that is located between the F and D. We use it to find this component throughout this equation. F equal F net cosine. Here, this is the horizontal component. We can also call it Fx. Now, from the equation, the topic of relations, once again, يعني, if you know me in the classes, I always mention that the relations in physics are a very important thing. And here you have a direct proportion between who and who, between work and force, and work and displacement. Yani work with, let's see, we did not write stuff. F and W have a direct proportion. D and W also have a direct proportion because they are directly related. What does that mean? If we double the force, work will be doubled. If we double the displacement, work could also be doubled. So this is something to keep in mind. They are directly proportional. But between force and displacement, there is what? There is an inverse proportion between F and D. So keep that in your mind because it will help us a lot later on, especially in the chapter review question 2. Sorry, I mean section review question 2. That's a very important question. We will get into it later. Now we need to understand how this cosine work actually. This is a very general concept in physics in grade 11 and 12, and in all the topics of physics that you will study, is that the theta that we use in the equations or the formulas is very effective. And the way that it works with the angles. So you have three cases that are possible to happen. Let's see one by one. So the first case that we have here, this one, is called the perpendicular case. When it happens when theta is 90. How can that be possible? Let's see. When you have a displacement going to the right and you apply force going to the north, let's say, which means up, you are not applying any force, any work, sorry, in that case. Why is that the case? Because imagine this person here, this worker, want to move this box horizontally to the right, but he's applying force upward to the north. This force that he's applying is not moving the box at all, so he's not doing work at all on this box. How we can explain this in physics? We say that this 90 degrees, when we put it in the cosine of 90 gonna give us 0. And then when you put 0 in this equation, this whole thing going to be 0 also. So work going to be 0. So when they are perpendicular and F and D are perpendicular, work is 0 because the angle is 0. When they are parallel, parallel means they are exactly in the same direction. The angle between them is 0. When the angle is 0 and you put it in the cosine, cosine of 0 is 1. So the work gonna be maximum. This is something that you should know. Cosine can give you, the sine and cosine, both of them, the maximum value that you can get out of them is 1. So this is why we call it maximum work. And here we call it minimum, which is 0. So this is this is minimum 0 work, and this is maximum total work and maximum work. And in between, this is called partial work. When it happens, when you have the force being applied at a specific angle. So in here you will have a partial work. So the theta will be between 0 and between 90, because when it's 90, your work is 0. When it's 0, your work is maximum. So between them gonna result a partial work. That's the idea behind it. And then we have the last important note that we have in here about the measurement of the work, which is the mass. Sorry, sometimes the question does not give you force directly. They give you mass. And what you need to do in that case, you have to change the mass that is given to you to a force. How you do that? You say F equal mg, which is basically the gravitational force. Fg equal mg. You multiply that mass that is given to you by the question by the acceleration of gravity, acceleration of free fall, which is the 9.81, by the mass that is given to you, and that's it, you have your work. This is something that you will be doing a lot in grade 12. Okay. Now the confusing part, which is why the work have a sign. We already said it's a scalar quantity, so it must not have a sign. But the sign in it in here does not represent a direction. What does it represent is when force and displacement are in the same direction, it will have a positive sign. When they are in the opposite direction, you will have a negative sign. That's all it means. And if they are perpendicular, this is 0. We discussed that already. So this is what we need to focus on. If they are in the same direction, that's going to be a positive work when they are in the same. So pushing or pulling doesn't matter as long as that you are putting a force that supports the displacement, supports the motion. So this will be a positive work and a positive acceleration also, if you remember from chapter 1. Now I will remind you also about it, because work have the same sign of acceleration. When you increase the motion, this is acceleration. When you do the opposite, when you're working against the motion, this is deceleration or negative work. So in general, in shortcut, yani, positive work, acceleration, negative work, deceleration, as you can see in here. This side has positive because you are supporting the motion in both cases, positive work, and with it, positive acceleration. In this case, this side, you are working against the motion in both cases, so you have a negative work and negative acceleration. Now we start with the questions. Question sample 4a. You have to you here and the question, given everything that you need. Actually, they gave you the force and the displacement and the theta, so you just plug in them right away into the equation and use your calculator to find the answer. But please don't forget to put the joule, which is the unit of the work. So actually, majority of these questions are basically asking you to find the work by giving you all the information that you need, which is basically the force and the displacement. The only trick they can apply in here, if they gave you the unit of displacement like this one by kilometer, do not use it. Change it to meter, then use it. How you do so? You just multiply it by 1,000 or 10 to the power of 3, then you plug it in directly. That's it. The other thing you need to pay attention to is that if they did not mention any angle in the question, such as this question, they gave you the Newton, which is force, and they gave you the kilometer displacement, but you don't see any angle in here. So you right away write theta equal to 0. What that will does, it will make the cosine theta equal to 1. So you just can ignore it. You don't need to write it. Work equal FD. In that case, cosine is negligible. Okay. The other part they can trick us with is that they did not give us the force, they gave us mass. Let's see if this one, no, this one gave us the force because you can see here 315 newtons and 2 meters. So this is the displacement and that's the force. And there is no theta, so theta equal to 0. So right away, work equal FD, you multiply them and 700. Okay, let's see this question now. Also Newton, also meter, the same thing, but this one have what 25 degrees downward. So you should put a negative 25 degrees in the theta. This is basically important to do actually, but in this exact equation, it's not going to have an effect. Why is that? Because cosine is a even function. When you put a negative sign in it, it will not affect it. Such as the square. When you put negative 2 squared, the negative will disappear. The same thing with the cosine. If you put negative into it, it will not affect it. Anyways, when you multiply them, you will have this answer. And we are done with this question. Now, that question is the interesting one. Question 4. This question, you will have two things changed. First thing, you have given to you the work, and you have mass given to you, and they ask you to find how far, which means displacement. There is no mention of the angle, so theta is 0. So the equation is W equal FD. You want to find D, so you divide F by both sides. So D going to equal to what? Work over force. Cosine theta is just 1, it's not going to affect us, but here we don't have force. What we do instead, we use the mass that is given to us. It was given by gram, we have to change it to kilogram, don't forget that, divided by 1,000. Then we multiply it by g, which is the gravity of, the acceleration of gravity, which is 9.81. Those two will give us the force that we need, the F. So work over F give us this answer. This is important question to keep in mind. The section review, here you have a couple of cases that is basically telling you about forces either in the same direction with displacement or in opposite direction. So the first case that you have in here, the road is basically stopping the car, so it works against the car, so work is negative in that case. And second one, you have the rope is pulling a bucket upward, so both of them are pointing up, both of them in the same direction, so positive. Last case, a parachute with air. Parachute is moving downward and the air is pushing upward, so negative also. Last case, okay, that's the last important question that we will have in this chapter, and it's actually very interesting one. This question works about the relations, as I said before. So in here, it's comparing you and your neighbor. They are telling you that both of you are pushing a lawnmower, but your neighbor is pushing that lawnmower 4 times the displacement that you are pushing it for. So 4 times as far as you, which means his displacement is 4 times as yours. But